Well, then the next thing is how to make the decision. We have two methods. The first one is traditional method. Also called is the rejection region. Usually when we use it for t-test, when we use t-statistics, that we use the traditional method. We have briefly went over reject null hypotheses. If test statistic falls in the rejection region, I tend to fail to reject the null hypothesis. It's not fall in the rejection region or falls outside the rejection region. Alright, so we had seen briefly what was it, right? If we have a rejection region, if out of that as the statistic, then it's failed to reject. If inside the rejection region, which fall into the shaded area, fall into the region, then we are rejecting null hypotheses. Right, two different cases, and usually we use for t-test. And the p-value method is a relatively new method. We have a critical value of alpha. We have a normal distribution of critical, not critical, of the test statistic of z-score. Then we find this area, and this area is called p-value. If the p-value is smaller than alpha, then we reject the null hypothesis. As we have seen, the alpha usually are 0.1, 0.05, and 0.01, and it will be provided in the question. And here, fail to reject if the p-value is bigger than or equal alpha. Right, so no matter what, right tail or left tail test, or even two tail test, if the test statistic is a z-score, then we are able to find the p-value of it. Then if the p-value is less than alpha, we reject HO. If the p-value is not less than alpha, in other words greater than or equal alpha, then fail to reject the null hypothesis. Right, of course, the t-score, z-score, both of them can find the p-value, but actually our table here to use z-score to find the p-value is more convenient. To use t-score to find the probability is not that much convenient to do, right? We are able to find the critical value and rejection region more easily for the t-test, and for the z-value method, the p-value method, the z-test is a little easier to do. Right, so far is the components. Like what we have seen, so many things was still the components. And to do the question, right, we'll see the procedure, how to do the question. So far at least we know what the components means, right? And based on what we need to know, right? So to wrap everything up, the procedures. The first step is to identify the null and alternative hypotheses. Then, of course, we need to pull out all the information from the question, right? Like what we do from the last chapter. Everything from the question is what we need to pull out. Then identify the null and alternative hypotheses. Find the test statistic. Right, for the population mean, we're doing when sigma is given, have condition of normal or sample size is large. I'll have the z-test. So when sigma is given, follow condition normal or size is large enough, could be both. Then we follow the z-test. If sigma is not given, but still the population is normal or sample size is large enough, we use the t-test. Of course, t-test we will talk about the degree of freedom, and that is sample size minus 1. If we use traditional method, in other words, if we get the t-test, if our test statistic is t-test, then we use traditional method, we need to find critical value and the rejection region. If we use p-value, if we use the p-value method, we need to find the p-value basically. That's the first three steps, right? To identify them, to find the test statistic, and for the traditional method, to find critical value and the rejection region. For the p-value method, I find the p-value. And then the next step, if we use the traditional method, right, compare the test statistic to the critical value. Or if we use p-value method, we need to compare p-value to the significant level. Both of them we are required to draw the density curve. We're able to draw the t density, we're able to draw the z density to make sure what we are doing. Then after that, I will get some clue, we'll make decision. One make decision about the null hypothesis, either to reject it or fail to reject the null hypothesis. And finally, as what we do for the last chapter, right, we need to get a summary, draw a conclusion. The conclusion of what we are actually doing, right? Then that's what it is, to draw finally the conclusion of what we are doing. So 6 steps, what we need to follow. And well, still seems like not that pretty much clear how to follow, how to do the full procedure. And let's see some examples. Then it should be very clear. This one looks pretty much familiar already. A simple random sample of 106 body temperature of healthy adults has a mean of 98.2 degrees Fahrenheit. Well, I believe we had seen the similar question as we seen in the last chapter. And the second sentence tells us, well, research suggests that the true standard deviation of body temperature of healthy adults is 0.62 degrees Fahrenheit. Well, based on this sample, such we get 106 people to get temperature of 98.2 degrees Fahrenheit. Well, based on this sample, the researcher believes that the true mean body temperature of healthy adults is below 98.6 degrees Fahrenheit, which was commonly believed. Right, what we need to do is test this claim under 5% significance level. Right, so a couple things are being shown. Well, we have a simple random sample of 106 healthy adults' body temperature, and the mean is 98.2 degrees Fahrenheit. What this sentence tells us is the group of 106 healthy adults has a mean body temperature of 98.2 degrees Fahrenheit. So specifically, this mean is the mean from this 106 people. In other words, it's the mean from the sample, which is called sample mean. Right, research suggests, which this wording is more general, right? Compared to the first one, is specific sample mean from those 106 people, and the second sentence is more general, the true standard deviation, which we have seen the wording last chapter, right? The true standard deviation of the true mean, which means it's the data from the parameter. The true standard deviation is 0.62 degrees Fahrenheit. And based on this sample, a researcher believes that the true mean is below 98.2 as commonly believed. The true mean, which is the population mean, he or she believes that it is below 98.2 or 0.6 degrees Fahrenheit. And so test the claim under 5%. Significant level. Right, so that is what we're asking. So first of all, identify the null and alternative hypotheses. They are the claim about our population mean. So we give a column and put the mean of what happened. Right, the commonly believed was we made assumption of 98.6 degree Fahrenheit of the population mean of the body temperature, and the belief or the claim is that it is below. Alright, so a couple of things also we need to figure out. Right, the sample mean given is 98.2 degree Fahrenheit. The population standard deviation given is 0.62 degree Fahrenheit. Sample size is 106. And the level of significance, which is alpha, is 0.05. Right, those four things are what's given. Right? 106 people are selected, have the sample mean of 98.2 degree Fahrenheit. Research suggested that the true population standard deviation is 0.62 degree Fahrenheit, with the significant level of alpha to be 5%. The claim is about the true mean will be below 98.6 degree Fahrenheit, which was commonly believed it is 98.6 degree Fahrenheit. So that is all information being pulled out. And to find the probability, right, so this case, even though not measured, it's normally distributed, but sample size is large enough. When we're given the sigma, we are able to use the z-score. So before that, we need to find, as the last chapter doing, we need to find the sigma over radical n. In chapter 6, we found that first. We keep significantly enough digits of decimal. Then we use the z-score. To find 98.2 minus 98.6 divided by 0.0602. And when we subtract them, we get negative 0.4 divided by 0.0602, we'll get negative 6.64. Right, from that, negative 6.64, and we do the left tail test, we're able to find the p-value. Right, from the normal distribution, we already know what to do. Right, the p-value is the left tail, which we go to the table to looking for negative 0.64. And from the table, we'll see negative 3.5 or lower, we use the value of 0.0001. So we found the p-value is 0.0001, is the alpha we state was 5%, so p-value is less than alpha. What we have is, in conclusion, reject, not conclusion yet, in decision, right, accept If we reject the null hypothesis, we are rejecting it and accepting actually the alternative hypothesis. Or we accept the claim so that the mean is actually less than 98 0.6 degree Fahrenheit. Right, so that is the starting the claim and do the math. We'll find out the p-value, and we see the p-value is smaller than the alpha. That means we need to reject the null hypothesis. So what is actually that means? Right, so I erase the part here. We don't know what the true body temperature is, but from the hypothesis testing, we are finding out, well, we could claim that the population mean body temperature is below 98.6 degree Fahrenheit. So what that means? Conclusion. We're making an assumption, right? This fourth step is based on the assumption that the true population mean body temperature of the healthy adults is 98.6 degree Fahrenheit, then the probability of getting a simple random sample of 106 adults which means the probability to get a simple random sample of 106 adults has body temperature has a mean of 98.2 degree Fahrenheit or lower is only 0.0001. In the true case, that is much smaller than that, but that's what we have. Right? So the probability of getting a group to be that extreme is very, very low in other words. Therefore, we have strong evidence right, that was the reason. So the conclusion actually is here. And we have strong evidence that the true mean body temperature is below 98.6 degree Fahrenheit. Now this probability is significantly small, so we have the evidence is very strong. Right, the reason is, well, if it is 98.6 degree Fahrenheit, it's very unlikely to have such a sample with mean body temperature 98.2 degree Fahrenheit or lower. Right, so it is very unlikely to happen if the body temperature was 98.6, so that we have very strong evidence to support the claim that the true mean body temperature is below 98.6 degrees Fahrenheit. Okay, so that was the full procedure of how we do the math and how we do the conclusion here. We will see more example next time. Next time we'll see more example about the hypothesis testing. Not only the standard deviation of population is given, but also not given. We'll see a little difference in the wording, but we need to be able to distinguish them. Right, so that's what it is for today. I'll see you next time.